Welcome to 2061, which is Python statistics and data visualization for petroleum engineers. My name is Dr. Olorud. I'm an assistant professor of petroleum engineering here at LSU. I like to start the course with the Bloom's Pyramid of Learning, which is basically learning at different stages. And it gets more serious as you go up the triangle or the pyramid. The main purpose of including this slide is to point out that this course will operate at this level. So just memorizing whatever I cover in the slides is not going to cut it for this course. We need to be able to generate solutions. We need to be able to design applications, develop code to solve problems. That's actually the goal in this course. So it's going to really help you with your problem solving skills, and we'll get lots of opportunities to practice with guidance during the lab sessions. So it's a very hands-on course. You only get better at programming by programming. It's just like swimming. So just watching the videos and understanding the course material is not going to be good enough. You need to practice solving problems, and I will really facilitate that by giving you all sorts of practice problems week in, week out. At the beginning of every topic, I will provide this slide, which will help guide your learning. So when preparing for the quizzes, when preparing for the midterms, it's also good to take a look at these learning outcomes and make sure you are able to do all of this, right? These are the things you're going to be assessed on. So these will keep getting modified, and it will be tailored to each topic. Okay, let's get started with topic one. So topic one is Introduction to Petroleum Engineering Data Analysis using Python. So we will be using Python for data analysis. That's the bulk of the focus in this course. Petroleum engineering data typically comes from different sources. We have data coming from geophysical measurements, and these are the geophysical and seismic data. Seismic data is based on sound. So we send sound waves from the surface down to the subsurface. So we have some device that makes some noise. The sound goes down to the subsurface and is reflected back and picked up by some receivers at the surface. And then from the sound received, you're able to figure out the time it takes, the duration it takes for the sound wave to go down and back up, which gives you some form of interval transit time. And from that time, you're able to figure out the properties of the subsurface. So you're able to figure out the tops of your reservoir, the horizons. You can figure out if there are faults in the subsurface, and different lithologies containing water, those that could contain gas, and those that could contain oil. We typically use seismic data to figure out the oil-bearing sands. We also have petrophysical data, which could include data coming from cores. The cores are typically cylindrical. It's a sample from the subsurface. We have well logs, which we'll talk about shortly. We basically have your hole in the subsurface, right? The hole is your well, and then we run some electric devices into this hole, and these electric devices basically send some signals or receive some signals from the formation, and then we're able to infer properties of the rock from these electrical measurements. We also have production logs, which are like your regular well logs, except that we typically run these in wells that are under production. So this could give us indications of the saturation in the well. One common use of production logs is in horizontal wells that are beginning to produce water. So originally, say this was the water oil contact, and due to production, maybe the water is breaking in at the toe, for instance, but there is no easy way to know that the water is breaking out from breaking through from the toe from just the production data. So you can run a well log, and the well log gives you saturation at these different points in the lateral portion of the well. And if you notice, saturation, water saturation is basically 1 close to the toe, then you know the water is coming from the toe, and then you can design some operations to go in there and say terminate the well at this point so that the water stops coming in. So that's one of the uses of production logs. We have image logs, which basically gives you an image of this wellbore. So the wellbore is cylindrical, right? And so because it's like you have a camera, some form of camera that sees the lithologies in the wellbore. And when you open up a cylinder, what do you get? A rectangle. So the image logs look like this, and then it goes from 0 degrees to 360 degrees, but we typically use the azimuth north, east, west, south. And then you can see the bedding planes, you can see fractures, you can see the average orientation of fractures in the wellbore, and so on. We also have specialized core analysis data, which is what we use to obtain the relative permeability and the capillary pressure, and those are typically plotted against saturation. We have PVT data, which are fluid property data. We have production data, typically just oil rate, water rate, gas rate against time. We have pressure transient data, which basically implies your rate is maintained at a constant value, typically 0, meaning we shorten the well and then watch the pressure build up, and then we analyze the data on the pressure build up. We have rate transient analysis, where the pressure is kept constant, and then we observe the variation in the rates and we infer the properties of the formation from the rate transient analysis. Real life data is always very messy. We will look at this Volve data set, and we'll be working with this a lot throughout this course. This is an example of seismic data. We are looking at one slice from a seismic cube, and like I said, this could be the top of a formation, this could be the base of another formation, this could be a fault. You can see that fault running through here, which has been mapped out. So you're able to see different geological structures from these amplitudes. The reds are the peaks, the blues are the troughs in these seismic waves. Petrophysical data, we talked about those before. These are well logs. This is your gamma ray log. This is your resistivity logs, bulk density, neutron porosity, and some of these are actually calculated. They're not coming from the equipment directly. So we have volume of shale, we have saturations, we have effective porosity, total porosity, and so on. So the data coming from the electrical devices are plotted against depth in your well logs. And these, as expected, will give you information about the rocks. When you understand the properties of the subsurface, then you will be able to predict how much oil you will produce and how quickly you can produce the oil. This will be the last slide in this video. It's on data visualization and analysis. The petroleum engineering data showed in the previous slides are very different because they come from different sources, and the purpose of those data are different. In some cases, we just need to visualize them. In some cases, in most of the cases, you need to do something with the data. You need to summarize it, analyze it, or make predictions. For instance, those oil, water, gas rates. We can have historical data for these against time. And then we need to make predictions moving forward so that we can be able to determine how much money we will make from the well if it continues producing versus how much money it costs us to keep the well running. So there are so many reasons to make predictions. It's important to be able to summarize and analyze data, and that's where statistics plays a major role, right? And over the last 10 years, there has been an explosion in the size of data, and we've had entire careers created or becoming way more famous than they were 10 years ago. Careers like machine learning, engineering, cloud data analytics, all sorts of buzzwords have been thrown in the mix. And all of this is driven by computer programming, data analysis, and statistics, among others. I'll stop here and finish up this lecture in another video.